Okay. Okay, people are entering. Should see the desktop now. Okay. Can you hear me? Does everything seem to be working? You see the desktop? Okay, I have to
I hear you.
okay. Okay, I got the chat window up. Okay. Okay. All right. Okay. So first thing to remember is next week is fall break. If I remember right, the 12th and 13th fall break. So we won't actually meet again until a week from today. So we'll meet again next Thursday. All right. Okay. And I put up announcement. There's another homework assignment, but that's still lying. It's a lot. Here, refresh the page. There. It's not there yet. I hope it'll be up there this evening. Okay, so it's not. I wanted the announcement to be up there so I could point out to you that to look for it. I hope this evening or tomorrow. But it's not up there yet. Okay, okay, and it'll be about what we're talking about, events. You'll write an event-driven program. Okay, and want to talk more about what's in this folder, these two folders. I don't know if we'll start with the clipping algorithms today or not, because uh, there's still quite a bit to say about the event handling. A lot of interesting stuff to say about the event handling. So I think this is as good a time as any to talk about it. Though after you see the homework assignment, you'll have a lot more questions about event handling. This stuff is kind of abstract, so it isn't until you try to do it that you start realizing how tricky it is. Okay, so let me download these two folders. Okay. Hmm. Okay. Um, the goal is to be able to tie events to our graphics programs. Okay, so the goal is to be able to do something like, uh, yeah, like this, that where the program, I'm typing at the keyboard, I can change the model, I can make the models move back, I can make them move sideways. I'm using the different keys. If I want, over on the left is a little message that says what keys do what. Now, right now, this thing only interacts with the keyboard. This I I haven't added any mouse features to these demos yet. And your homework assignment, though, you'll be working with the keyboard and the mouse. Okay, but we want to be able to have the renderer respond to events like a game would from the keyboard. Okay, all right. So that's now we know about how to draw. Like this is just the scene. I'm changing the model in the scene. So I've got a scene, and what I'm doing with this key, when I tap this slash key, the uh, the slash key cycle through the models just changes what models in each scene. Okay, and then the drawing the model is actually no different than what we talked about. So the only actually this render is the render from the previous one with only one file added to it. The file in the frame buffer, this one here that ties the frame buffer to the GUI. That's the bridge from our frame buffer class to the GUI class. Okay. Okay. And what that does, remember, the outline of how you should think about graphics programming. There's 5 things to think about, right? Components, containers, layout managers, events, and listeners, okay? Oops, I'm sorry. What this class does is it makes our frame buffer into a component, okay? Like a button or a so you have all these components, labels, buttons, checkboxes, combo box. Well, if you want to, you could think about adding another item to that list, a frame buffer panel. In fact, yeah. Now, it's not a container. It turns out that panels are containers, but they actually also are graphics. What used to be called a canvas. The J panel is also what used to be called a canvas, something you draw on. So it actually does double duty. It is a container to organize components in, but it also gives you a blank slate to draw on. So I made a subclass of JPanel, and think of it as a canvas, and you paint the frame buffer on it. So, but that makes this guy a component that you can add along with buttons and lists. You know, you can just, now notice that over here, I'm running it full screen. Let's see, I shut that demo down. If I go back to that little demo I was running, you don't get the feel that it's a component in a GUI because I'm running the renderer as the whole window. I didn't put anything else in that window. And later we'll do an example where there's some buttons and some other things on, and the renderer will just be one piece of the GUI. That would be much more like a more modern thing. Like right now, the render is the whole GUI. So I've created a J-frame, which is the window, and that J-frame is filled with one J-panel, which is our renderer J-panel. Okay, so this is real simple. There's just the top level container, the J-frame, holding one single component, a J-panel, but it's a J-panel that's filled with our frame buffer. So it doesn't look GUI-like. Yeah, so and we'll make it look more GUI-like soon. But it does respond to keyboard events, okay? So it does respond to keyboard events, okay? All right, so that's what we've done. We're using the GUI system. As we could go back here, this file here makes the frame buffer a component, okay? So you can, yeah, like I say, you can treat it as one of these guys. You know, it's a first class component, just like any one of these. You can build up a complex GUI out of scroll bars and radio buttons and sliders and check boxes and now frame buffer panels. Okay, all right. So and you could and remember you could give this frame buffer panel to a flow layout or a border layout. You know, the layout managers would know how to handle this frame buffer panel. So the frame buffer panel would fit into the GUI well with all these other things. Okay. Now that's one aspect of all this. Then the other, that's this aspect, what things look like. So the frame buffer is now just a component in the GUI. But what the harder part is this part. How do you tie events to your GUI? How do you make your GUI do something? Yeah, it's one thing to just display something. Yeah, in fact, oh, I shouldn't have closed it down. That example I was looking at, yeah, if you don't know better, you might think it's just displaying a picture. You know, it doesn't really look GUI-like. It didn't really look like it was. From this point of view, it doesn't even look GUI-like. So it just looks like I'm displaying a picture. Yeah, I'm not really just displaying a picture because it's interactive, but you know, it just does look like it's displaying a picture. Okay, and as a component, you could just use this part here to display a picture. Or so you could display the render showing a scene, but if you want it to be interactive, that's where these two come in, events and listeners. Yeah, if you want the picture on the screen to be updated by either a mouse click or a keyboard action or some other thing. If you want this thing to change, you have to tie what's being displayed by these guys to the events that the user does. Okay, so you can build static GUIs with just these. Not many people would ever do that. I don't, every once in a while, somebody does write a program that just puts up a window and the window doesn't do anything. You probably can find examples like that. So you might actually want to write a static GUI, and then you wouldn't need these two. But usually the whole point of GUIs is to tie them to these. Okay, but they're really kind of separate issues. What does it look like? In HTML, this is very separate. What does it look like from how does it act? In web applications, this is all HTML and CSS, and this is all JavaScript. If you're doing GUIs in web pages, it's really kind of dramatic how these two pieces are separated. Okay, this is all HTML and CSS, and this is all JavaScript. And then there's a way to, the JavaScript can communicate with these things. But here we're doing this all in Java. We don't have 5 languages to worry about: HTML, cascading style sheets, JavaScript. There's at least 3. You have at least 3 languages to worry about. And you probably have some others. We only have 1 language, Java. Everything's being written in Java. Okay, but there is still this clear distinction between what it looks like and how it behaves. Okay. Now, let's go back to kind of talking about the how it behaves. That's the harder part. Okay. Okay. Now, what we want to do is write are called event handlers. And I've written a whole bunch of different demonstrations of event handlers. There's 5 different versions here. And if you download this other folder, this one on GUIs, there's a whole bunch of different versions of event handlers. And unfortunately, there's no one way that people tell you to do event handling in Java. Same thing is true of HTML. It's even far worse with HTML. There's no one right way to do this. And if you start thumbing through books or looking at tutorials or asking questions on Stack Overflow, you'll start seeing answers that don't look at all like, because everybody's got their own idea of what the right way to do things are. So here I have a folder called How to Handle Handlers. And there's 15 files that go from a super simple way to handle handlers up to a more complicated way. And they're just showing you different ways. And there's not 15 ways. It's almost 15 ways. There's almost 15 different ways. Every one of them you'll find on somebody's tutorial or in somebody's textbook. And then, now these use the render. These examples, I'll just show you one of them. We'll look at the example, what it does in a minute, but like what it does is pops up, oops, that one's, oh, I got a bug in that one. That number is supposed to be a 2. I was modifying these earlier, and I forgot to catch some of the 2s. Okay, so it draws a sphere. Okay, right now, that's just building a sphere model, giving it to this, instantiating a sphere model, putting it in the scene graph under the scene, then handing the scene over to the frame buffer, and the frame buffer renders it. The renderer renders it in the frame buffer. But if you hit the space bar, it moves. Okay. That's, it doesn't do anything else but go backwards. You can't even make it go forward. So it's real simple. Okay. So I've tied event handling to the renderer. So all the examples in this folder, they draw a sphere and they just let you hit the space bar and the sphere goes backwards. But the key is they do it a bunch of different ways. So they all look like they're the exact same program. Okay, but they're not. They're very differently written, but they all do exactly the same thing. So, what's different about them are the subtleties of what we want to talk about a little bit. What makes version 3 different than version 4 than version 5? And if you open them, they each have a little opening paragraph that tells you like what I changed from one to the other. They usually have they're not big changes from one to the other, but there's small changes, but I try to tell you what each one does when it changes from this one to this one to this one. They're each using a slightly different style that you will find in different textbooks. And I'm trying to show you like how you would progress from a simpler style to a more complicated style and why some styles are better than others. The simpler ones are usually better because they're simpler and easier to explain. The more complicated ones are better because they're less prone to weird effects or bugs. So there's a good reason for all of these. Some books don't want to get into tricky issues, so they stick with somewhat buggy, simple issues, or they stick with a design pattern that won't let you write very complex problems. So some books, but then they don't tell you that. One of the problems is if you read these in books, they'll do maybe a real simple example, but not tell you that this is a very simple example that isn't going to get you very far. They don't always warn you. So then when you look at another book and it looks really different, you're wondering, well, and even if they might even start, another book might even start with a more complicated example from the beginning. And you're wondering like, why are these so different? So this tries to step you through all the different styles. Now, there's another folder here called Event Dispatch Thread Demos. Does kind of the same thing, but with a button instead of the, here, it's building up GUIs, but not using the renderer, just using usually a button as the thing that's being rendered. So instead of there being a GUI in here, there's a button, and when you click the button, it just says ouch over there, okay? That one had a timer in it. Notice that it disappeared on us because that one had a timer in it, okay? So the difference between this folder about events and this folder about events is that this one uses the renderer and this one just uses a button. And then there's another folder that, again, does something real similar. This one called Watch Events. But what Watch Events does is each example is emphasizing one kind of events. Remember, in this outline, there are 8 kinds of events. That's how Java gives you 8 kinds of events: action, item, text, adjustment, focus, key, mouse, and window. Okay, gives you 8 kinds of events. So over here, watch action. We'll watch action tied to a timer, watch adjustment, watch component, watch focus, watch item, watch key, watch mouse, mouse motion, mouse wheel. There's actually, the mouse thing is kind of tricky. There's actually 3 different versions of mouse events. So there's mouse, mouse motion, and mouse wheel, and then window. Okay, so each of these just only show you one of these kinds of events. The way you read this is an action event can be created by a button, a list, a text field, or a menu item. So these components share that kind of an event. These components share that kind of event. Now, what's tricky, and this stuff it's weird. I'm not even sure why they did this. Notice that lists produce both item events and action events. So a drop-down list, simultaneously creates an item event and a action event. And action events can be from buttons in lists or from checkboxes in lists, for example. Okay, a text field generates both an action event and a text event. Okay, let's see. Adjustment events only come from scroll bars. You adjust a scroll bar. So only the scroll bar gives you adjustment events. Okay, so it's kind of weird how some of these events, there's, you can't say, well, button only creates an action event, but list creates 2 kinds. Okay. these events down here are called low-level events, and these are called high-level events. And as we do some examples, we'll see a little bit how it works. But like, take the mouse, for example. Okay. The mouse event comes from a window. Like, see, I'm over in this window. So now that window is generating mouse events. But if I hover over a button in that window, it's not clear, should the mouse event go to the button or should it go to the window? Okay. Now, that's different than an action event. An action event means I'm actually over a button and I click on it. So I get an action event when I'm over a button and I click on it. So action events directly come from buttons. But there's something different about the mouse event. The mouse is floating around. So right now, that window's getting the mouse event. Right now, you could either say that both the button and the window are getting the mouse event, or you might say, oh no, at this point, only the button gets the mouse event, but the window doesn't anymore. And that's actually the way Java does it. Some do it differently. But right now, the mouse event's just going to the window, to nobody specifically, just to the window, because I'm not over any other component. But then if I start hovering over components, the mouse event can either go directly to that component and not go to the window, or it could go to both. Okay, and the way Java does, now that's why it's called a low-level event. It could be not tied to any component. High-level events come directly from a component. You only get an action event if you're on top of a button and you click. If you're over here and you click, there's no action event because there's nothing to act on. You don't give an action event to a window. Okay, you only give an action event to a specific component, either a specific button, a specific list, or a specific text field. So when I click the mouse over a button, then I get an action event. If I click the mouse over here, I get a mouse event. I get kind of a generic, we'll see, it's called mouse down. So if I click over here, I just get a generic mouse event. When I'm over here, I get the generic mouse event, but it goes to the button, and the button also gets the action event. So there's a lot of complexity to this. Yeah, and in some libraries, in some systems, when I click over here, the window will get the mouse event, the button will get the mouse event, and the button will get the action event if I click over here. So that's what this kind of shows you a little bit of. It shows you these different, like, oh, I can show you that. I think it's this. Okay. Notice that the mouse went in the window, mouse came out the window, mouse went in the window, mouse came out the window, mouse came in the window, mouse click down, mouse click up, but not dragging. This is just mouse events, not mouse motion events. Okay, so this thing is detecting that I enter and leave the window. Those are mouse events, and these are the low-level mouse events. It's just the window getting them. Okay, now let me look at that one more carefully. I can add a button to it. So I made the button. You change the code, you add the button to the example. Now let's see how that changes it a little bit. Okay. I enter the window, leave the window, enter the window, leave the window. Click, click, click. See, now watch here. Now notice what happened there. See, there's nothing happening here. Now, why is there an event there? Look at the bottom, see what it says. Did anybody see what happened? What was the event? What's this event?
Your mouse enters and leaves the button area.
Yeah. See, here's the mouse is doing what?
Enter and leaving the window.
Entering and leaving the window. Now the window's now kind of divided between the window and the button. Now here I entered the mouse. The mouse entered the button and left the window and entered the button. Here, if I click, I get events. Who's getting the mouse clicks now? Where are they going?
Button.
To the button. And I don't have an event handler on the button right now. So see, Java took the point of view that this low-level event, the mouse event, when it's on a button, it shouldn't go to the window. The mouse event should go to the window, the button. Now that later on, we'll see that that button is actually getting two events every time I click. It's getting a low-level mouse event, and it's actually getting also the action event of clicking a button. Clicking a button generates an action event, but if I'm over a button, it also creates a mouse event. But the mouse event goes to the button. Okay, so this is the kind of tricky thing. Yeah, these little simple demo programs help us see these little distinctions. That's why I built all these like real simple little demo programs. Okay, so mouse in, mouse out, mouse in, mouse out, mouse in, mouse click, mouse click, mouse click. But now, oh, the mouse is no longer, well, the mouse is still in the window, but it's over a component. So now the component has priority over the window. So the event goes to the mouse, the button. Okay, so the button is getting all the events from the mouse now. Okay, all right, so that's the difference between these low-level events. The low-level events kind of are shared, and they get shared between the window and the components themselves. The high-level events are specifically about a component. You only get a high-level event when you click on a checkbox or a list. If you click on a checkbox, you get an item event. If you click on a list, you'll get an item event and an action event. Never quite understood why. There must be a good reason. I mean, I probably just have never written enough GUIs to know exactly why they want both an item event and an action event for a list. But a button only does an action event. Okay. All right. So what they call high-level events belong to specific components, and what are called low-level events are kind of like shared. What? Sorry, say something? Okay. All right. All right. So I end up with 3 different folders that are all kind of showing you the same thing. Simple little demo programs of event handling, simple little demo programs of event handling, simple little demo programs of event handling. But each folder is trying to emphasize a little bit different thing. This one's emphasizing different components. This one's emphasizing our renderer, tying our renderer to, actually it's always the same thing, the keyboard. But how many different ways can you tie our renderer just to the keyboard, not even to the mouse or anything like that? So here, everything is about tying the render to a keyboard action, but there's all these different ways to tie the renderer to a keyboard action. This folder takes the point of view of like, how many different components can you have? Okay, and how do you tie a little action? How do you watch the actions, the events from all the different components? So this one goes through buttons. It goes through, well, it doesn't go through every kind of component. It goes through every kind of event. So for like action event, I think it uses a button and it doesn't do these other ones. So for the action event one, it uses it uses a combo box. Okay, it uses a combo box for the, I'm sorry, spam phone call. Okay, it uses a combo box for the action event. Okay, I didn't even have combo box in this list here. I forgot to put it. Yeah, combo box is up here. And I should have put combo box as one of the things that generates action events. Okay, button, list, text fields, menu items, and combo box generates action events. Okay, so I used like in this example, I used a combo box to generate the action events. Okay, I could have used a button. Yeah, so, but here instead of exhaustively giving you every kind of action event, one from a button, one from a list, the emphasis is on the kind of event, action. This one does action with a timer. So that's one of the things another one that can give you an action event, I probably should have put it in the list, is a timer object. Adjustment, well, adjustment only comes from a scroll bar. Component can come from any component. Component can come from anything. It's a low-level event that can come from any one of these things. Okay, focus. Okay, item is one of these. I forget which one I used for item. For item, I used another combo box. So combo box also generates item events. So I should have put combo box in both. I should have put combo box in both. Just like see, a button only generates an action event. A checkbox only generates an item event, but a combo box generates both an action event and an item event. So you can do them separately. So in this program, it watches the combo box for the item events, and the other one watches the combo box for the action events. And if you run them side by side, you might start getting a sense of like, when does a combo box generate actions and when does it generate items? When does it create action events and when does it create item events? Okay. There's the combo box. Notice there's a little bug in the program. That's on purpose. Okay. Watch item. Where's the combo box? If you resize the window a little bit, it appears. That's actually a bug in there on purpose to show you that this stuff, we'll have to solve that bug later. Then there's action event. Same bug, you have to adjust the window and there's the combo box. Okay, so this one's actions. Oh, we actually need the side one. This one is action. So this guy's output appears down here. And the other one is item events. Okay. Okay. So no event yet. No event yet. Okay. That created an action event. That created an item event. And actually, I'm not even sure there's any difference between them. Okay. Now, notice that there's no events yet. Those would be mouse events. If I was really paying attention to, I could find out by mouse events that someone's doing this, but there's no event happening yet. And if let's see, right now I'm item 2. So if I click on item 2, nothing happens. See, that's not an event because item 2 is the selected item. So selecting it doesn't cause an event. What about over here? Select item 2 again. See, there's a difference. If item 2 is the selected event and I click on item 2, I still get an action event. Okay, so reselecting item 2 is an action event, but reselecting item 2 is not an item event. Think of it. What's their rationale? It does make a little bit of sense. What's their rationale? Think like a designer. Why no event here? Why event here? Think of the name.
Oh, yeah, well, the action example, an action happened, which was you clicked on it.
Yes, yeah. I actually did have an action. On the other hand, what about over this one?
So that one just says item example, and so since it's the same item, there's nothing.
No change. Yeah, so it makes sense. This is about items, and I'm not reselecting an item, so it doesn't give me an event. This one's about actions. So if I click on 2 again, I'm still doing something, so it gives me a new event down here. okay? And then if I select a different item, of course, I get an action event. And if I select a different item here, I get an item event, okay? Notice neither of them give me events if I just do this. If I just click on the little drop-down list, and that's kind of, now here you might think that drop-down list would be an action, but it's not. And I'm sure there is a way to ask, let me know if they click on the drop-down list, but that's neither an action event nor an item event. You might have to do that just with raw mouse events. But notice that, so right now I'm not getting anything from that thing there. Okay. So what we're doing is I called the folder watch events because you want to be able to watch how these guys behave. How is the underlying GUI system actually behaving to give you the tools you need to write programs? Okay, now here's where things get weird. Like right now I'm showing you the Java GUI, specifically what's called the Swing GUI library. Java has another GUI library called Java FX. Then there's Windows has, I think, 6 different GUI libraries, literally. Microsoft, with every release of Windows, Microsoft cooks up a new GUI library. Okay, so Windows 10 had a new GUI library. Windows 8 had a new GUI library. Windows 7 had it, and they're all right. They're kind of piling up. I think there's currently something like 6 or 7 GUI libraries. They can differ in how they be. They'll all have checkboxes like the combo boxes. Every GUI library has a combo box. But how you divide up the events from a combo box can vary hugely from one library to another. Like Java Swing gives combo boxes 2 kinds of events. And neither of them detect this. Now, it could very well be that like one of Windows libraries gives a combo box only 1 kind of event, or maybe it gives it 3 kinds of events. Who knows what they give it? So when you switch from one library to another, you have to start really thinking about how did they structure their events. Now, let me give you something to think about. Given that a combo box can have, say, 2 events in one library, but 3 events in another library, imagine how hard it is to write a GUI that runs on both Apple's Macs, Apple's Windows, and Linux. It actually is extraordinarily difficult. And now you can kind of see why. You put a combo box in your GUI, but you don't have like one simple little thing to worry about. On an Apple, the combo box could generate 3 or 4 different events. On another GUI, the combo box might generate 2 different events. On another GUI, the combo box might generate everything's in 1 event. So there might even be 1 event from the combo box, and it tells you everything. Notice that there's a lot of information in the, you could just bundle a huge amount of information in the event and just throw 1 event. Anytime anybody does anything over here, you generate 1 event with just a huge amount of information in it. This makes trying to write cross-platform GUIs nightmarish, because something as simple as a combo box doesn't have to act anything alike from one library to another. So we're using Java's Swing library, and we're seeing how it is an example of a GUI library. You can't think that, oh, combo boxes generate 2 events. No, combo boxes, you don't have a clue what a combo box does until you read the documentation of whatever library you happen to be using. Could be 1 event that just bundles a boatload of information into the 1 event. It could be 1 event for this, 1 event for this, 1 event for that. 1 event for clicking on this, 1 event for clicking on an item, 1 event for changing the item. It could just be 3, 4 different events even. Okay, so the watch event programs I wrote were to show you how you can just watch 1 kind of event at a time. Just watch 1. Now here, the combo box. That's why I used the combo box for this, so that we could even see, well, how did they separate item events from action events for a combo box? Because combo box is one of the ones that lets us do both. I could have also done something with a text field, because a text field generates action events and, text field generates action events and text events. So you could create a couple examples where, like, what's the difference between an action event from a text field and a text event from a text field? How are those separated? Why didn't they just have one event from a text field and just bundle a ton of information in it? Why did they give you 2 events from a text field? Why did a button only need 1 event? You know, why did button only need 1 event? Okay. All right. So, oh, and combo box is a special case of list. I think that's what I was thinking when I made the list. A combo box, remember, it was a drop down. Sometimes people call the combo box a drop down list. So Java calls it a combo box. I think Windows calls those things drop down lists. Okay, so I think they actually do call it a list. I'm pretty sure that and I think that's a more common phrase for that GUI item. I think it's more commonly referred to by most people as a drop-down list. It's a list of items, and it doesn't drop down until you click on the little arrow. So I don't know why, I'm not sure why Java called them combo boxes. It's a combination of items, I guess. It's a box with a combination of items, but it's called a J combo box. But I think it's more commonly referred to as a drop-down list.
Does Java GUI offer a tree?
Yes. Yeah, I didn't put it in this list. There's a J tree. Oh,
Okay.
Go to that folder about Java GUIs.
All right.
I put 2 little shortcuts in there. They're kind of fun.
Okay.
Here's a little dictionary of all the components. Okay, let's see if trees in there. It's a dictionary of a lot of components. It's not everything. So let's see. Does anybody see a tree in here?
Yeah, trees on, scroll
Yep.
down.
Yeah,
Right.
J trees to the right, right
Yeah.
there. Yep.
Oh, there. Yeah, it is. There's J tree. Mm-hmm. So they give you a visual picture of what they're not programs. Yeah. So that none of these are live. They're just screenshots. But they give you they let you see what each one of these components look like. Okay. And this page originally came from the Java tutorial, but for some reason, the people at the Java tutorial page didn't like this page anymore, and they deleted it. Notice that this one's being hosted at MIT. Somebody at MIT said, that's a great page. I'm going to put it up on my website so you can still see it. But it was deleted from the actual tutorial itself. It's no longer there as a tutorial. Now, on your hand, the tutorial has this page still there. This is a page that's a visual guide to layout managers. Yeah. Now this really suffers from not being dynamic. So you don't know what this thing does as you move. The whole point of a layout manager is how does this behave as you change the shape of that window? How does this behave as you change the shape? So yeah, but at least it gives you a kind of a clue to what the layout managers look like. Okay. This is still at the Java tutorial. But this page, they deleted it a few years ago from the tutorial. So somebody at MIT copied the page and put it up on their website as part of a course, I think. I think it's, they made it part, see, they copied, from the Java 6 tutorial. So it was from a while ago, but they stole this page from the tutorial app. When it got deleted from the tutorial, they put it up. I think it's a great page. It's just nice to see at least a simple visual representation of all the different components. Not all, but most of the components. Okay. All right, so I put a link to those 2 right there, so because they're kind of nice, they're kind of useful. Okay, all right. So now, what we're doing. All this stuff is split between 2 folders right now, and I haven't come up with a really good way of kind of organizing it. Right now, my idea is that this is the render, and this is the stuff about GUIs. And the only place where they overlap is this one folder, this one, that uses the GUI, the renderer to give examples. Okay, so this folder is the only one that uses the render. Everything else in this folder is really just about GUIs, not about our render. And then this is our render using events, and not really even using GUIs. Remember I said that in every one of these, the frame buffer is just shown essentially full screen. There's no other GUI item in the examples over here. So, you know, it doesn't feel very GUI-like because, you know, it's just there. You don't see anything but the frame buffer, and you don't see any GUI items. But this is a GUI. Remember, this is a component, but you can interact with it. So very light on the GUIs, but more emphasis on the events. And actually, but the only event here is keyboard. Right now, I'm restricted to just doing keyboard events. So this is every code, all the code in here is tying our renderer to the keyboard, basically. It's tying our renderer to the keyboard. Over here, it's trying to be a lot more about GUIs in general, sliders, drop-down lists, buttons, and it only brings in the GUI or the render in this one folder. Okay. Now, over here, in this one outlines how to tie the renderer to the GUI, but it mostly talks about events. And this is this paragraph here, this thing right here is really what's important. This is the mental model you need. All the code examples are basically showing you umpteen ways to instantiate this model. Okay, here's 5 different ways to instantiate this model here. In this folder here, I'm sorry, how to handle handlers. Here's 15 different ways to basically build up this model in the heap. So the key is to understand this model. Okay. Now, let's take a real simple example over here. Actually, no, it's not. And then let's use this folder. There's a lot of overlap between this folder, and this folder. Okay, there's a lot of overlap, and I think the overlap is useful. It might seem confusing, but they're each actually showing you something subtly different. And for example, I have not been able to come up with one single approach to this because it seems like it's just too complex. Yeah, it'd be nice if there was just saying, here, read this one sequence of examples, but it's just a little too complex for that. So I end up with 3 sequences of examples, this sequence of examples, this sequence of examples, and this sequence of examples. All of them are in some way or other building up this model a bunch of different ways. Okay, so I think let's try this one here. Use this as I think. Here's where you need more than one monitor too, because you have to start reading a bunch of things at once. What do you need to read? You need to read the code, the explanation of the code. You need your GUI item over here you can play with, and you need to watch what it says over here. Okay, all right. So there's the GUI, there's its output, and then here's the code, and then here's the explanation. Okay, all right. Now, here's the general high-level view. You've got a GUI object that generates events. That's this button. Okay, that's the GUI object that generates events. You know, when I click on it, I should see something happen when I click on it. Okay, but remember, this button doesn't know anything about it's being clicked on. It's the mouse that knows it. The button is just sitting there. It's the mouse that hovers over it and the user that clicks on it. The button doesn't know when it's going to be clicked or anything like that. When your user clicks on the mouse, it's the operating system that detects the click. So that's this guy here. When the operating system detects me clicking on that button, The operating system says, which window is that in? Oh, the Java Virtual Machines window. So the operating system sends a message to the Java Virtual Machine. The Java Virtual Machine takes that information and bundles it into an event object, okay? An event object is an object in the Java library. So here's another piece of information. There's the event object. It's not a class that you should be using, but it's because it's the Java Virtual Machine that builds these things. Okay, and notice that it's oh yeah, you can actually, it's got a public constructor. If you wanted to build your own event objects, you probably could. Yeah, maybe there's some really sophisticated programming models where you create your own event objects. Okay, but for the most part, we don't create these. They're created for us by the operating system. The operating system creates the event object, and it sticks into the event object all the information. When did somebody click on? It's actually got a timestamp. When was the mouse click? On what pixel was the mouse click? All kinds of information like that. Okay, so the operating system detects the mouse click. The operating system detects what window it's in. The operating system looks up who owns that window. The operating system sends a message to that process. In our case, it's the Java Virtual Machine. The Java Virtual Machine bundles that information into an event object. Then it wants to know what code of ours wants to be told about the mouse click. In this case, the code prints ouch. So how does the Java Virtual Machine know where our code is? Now, here is our code that handles the event. That's a different object. It's called the listener object. It holds the code that we want to have executed when there's a click. So we have to register our event listener with the button. Okay, so the button has a list of event listeners. So when the Java Virtual Machine builds this object, the Java Virtual Machine knows it came from this button. So the Java Virtual Machine goes to that button, goes to that object, looks in this list, looks for the code, and executes our code. Okay, all right? Now, how does all this happen? Okay, if we look at the code over here, here's the object that here's the class that describes the object that holds our ouch code. This is the class that describes the event handler. But you don't have an event handler until you instantiate one. So here's the line of code that instantiates this. Now this has to be instantiated long before any events happen. This has to be in place before any events happen. So this is happening in the main method. The main method builds the JFrame, creates the button, creates the button object. That's this guy. That's the GUI object. Creates the button object. Creates the button object. Creates the action listener object. Creates this guy. Now you need to tie them together. That's the next line of code. Add the item to the list in the button. Okay, so add that action item, add that code into the list of listeners in the button. So line 16 is the line that puts this object in the list of that object. We call that registering the event handler. We're registering, we're letting this Java system know that when an event comes in to this button, here's the code that should be executed. Okay, so create the button object, create the event handler object, register the event handler object. This little pattern is ubiquitous. Every GUI system has these 3 lines of code somewhere in them. Create the item that's going to create events, create the item that's going to handle the events, register the item with the source of the events. Register the handler with the source, so that now when you click that button, you call that code. Okay, all right. Now we're set up. Now we just make that visible. Then now this is all just happening in the heap. Then, well, we add the button to the frame so that we can, and then we make the frame visible. That starts everything going. when you make this thing visible, then you start the Java virtual machine thread that creates these event objects. Okay. Without this line of code here, if you don't make your GUI visible, there is nobody creating these event objects. The part of the Java virtual machine that creates the event objects isn't triggered until the GUI is visible. So if we showed that the other day, if you drop that line, nothing happens. There's no, you don't see the GUI, and there's no, if you don't see the GUI, it's hard to imagine there being any events. So that's kind of the idea. If you can't see the GUI, there shouldn't be any events. But when you start this guy up here, when you make this guy visible, you're starting the part of the Java virtual machine that accepts events from the operating system. Okay. Notice that at this point your program goes away. So the code that instantiated this, and put these guys together, that code disappears. And now we're executing a different thread, the event dispatch thread. The event dispatch thread, it's the thread that's creating these objects and calling this method. This method's not called on my main method. This method's called on the event dispatch thread. Okay, so this stuff was built on the main method. Then this stuff is built on, this objects are built on the event dispatch thread, and these guys are called on the event dispatch thread. Okay, you don't see that here. There's nothing here that says this is going to be run on the event dispatch thread. That's kind of invisible to you at this point. That's where you have to have this mental model. Otherwise, this is just a great big mystery. Your program ended there. So why didn't this, your program is, see, there's by. By meant that this code exited. Main method died. So what's going on over here? What's going on over here is the event dispatch thread. So all this is happening on the event dispatch thread. Okay. All right. So this is this is our starting example. We have a main method that builds this model, create the GUI object that generates the event, create the handler object that holds the code of what you want done when the event happens, tie the handler to the object using this list of event listeners, and then and then make this guy visible. Once you make this guy visible, this work is done, and the thread that does this can go away. The thread that built this can go away, and it does. And now you're left in the event dispatch thread waiting for the operating system to generate, waiting for the operating system to generate an object, pass it off to the Java virtual machine. The Java virtual machine builds this event object, and then the Java virtual machine says, well, it came from this GUI item, and this GUI item has a list of who I should now call. And then the Java virtual machine calls that method for you. And then if you notice, this method is never called in my code. It's never called in my code. So who called it? The answer is the Java virtual machine in the event dispatch thread. They called it. Okay. Now let's go to another version of this. Like that was version 2. Actually, what was version 1? Let's start at the beginning. What did version 1 do? Version 1 never made the GUI visible. Okay, so GUI 1 was showing you that if you do all this work, if you build all this stuff up here, doesn't mean anything if you don't somehow start the event dispatch thread. So the version 1, if you run it, nothing seems to happen, because we never launched the event, that we never made the GUI visible, and nothing happens. We built a GUI, but we didn't make it visible, and so there's no events or anything. Okay, so that just shows that. Okay, now what about version 3? Now so the only difference between version 1 and version 2 is that one line of code. Start the event dispatch thread. Okay, that's the only difference between 1 and 2. Okay, right? Now what about 3? Oh, do I have 3 open already? No. Okay, 3 says, what if we did this real quickly the other day. What if I just exit? That's going to kill the GUI. Okay, because exiting, notice that the point here was exiting this, okay, ending this method kills the main thread. Exiting kills all threads. So returning kills just the main thread. Exiting kills all threads, which includes the event dispatch thread. So even though I made it visible, I kill everything. So what you see is you see the GUI flash and dies. Okay, so the GUI got a chance, had like a split second to run, and then it dies. Okay, now 4 just puts a little delay in there. 4 says, oh, let me see the GUI for 5 seconds and then kill it. So 4 just shows you that this thread is still running for this thread goes to sleep for 5 seconds, and then it kills itself. And so you see the GUI for a brief period of time. The GUI's there, you can run it. Am I writing the right one? I thought I was.
It looks like it's version 5 that you ran.
Oh, yeah. Oh, I ran 5. I meant to run 4, right? Yeah, I ran 5. I meant to run 4. So 4 is the one that puts the GUI up for 5 seconds and then kills it. Okay, there's the GUI. It works. Oh, it's gone. See? And notice I never get the buy. I never get this buy because this killed everything. Okay, so while this thing's asleep, 2 threads are running. This thread is running while it's asleep, while the event dispatch thread is running. Okay, now version 6. No, I'm sorry. Next one is version 5. Version 5 gives 2 event handlers for 1 button. So that just shows that. I can close some of these now.
I have a question.
Uh-huh.
If you put the on version 4, if you put if you sleep the thread before you call set visible, what would happen? Would yeah, I want to know what happens.
Good point. Yeah, let's try it.
Would it never start the event dispatch?
Let's think about it. Okay, we know that builds the GUI, so that creates this picture here. Okay, so that creates that picture there. Now the thread sleeps, so everything just kind of pauses. Nothing's visible yet. Okay, then we make the GUI visible, but then what happens immediately after that?
All threads are killed.
Yeah. So what will happen is we'll see nothing, then we'll see a flash of the GUI, and then the GUI will die. So right now, this one should give us nothing for 5 seconds. Flash a GUI and dies. Okay, so you saw the GUI flash and then die. Okay, so the sleep just said don't start this. This paused us from starting the event dispatch thread. So since we didn't start the event dispatch thread, nothing was happening for 5 seconds. But then as soon as we started the event dispatch thread, this thing died, killed it. Now you might do this. What will this do now?
Keep the GUI. Keep all threads. No, keep the GUI.
Yeah,
live.
but so the program will start. Then what happens?
It'll sleep for 5 seconds.
Yeah, nothing happens for 5 seconds, and then
the main thread terminates and then the event dispatch continues.
Yeah, and so everything's, the program just pauses for 5 seconds and then the GUI appears. So it's just gonna, the GUI, okay, we go 1, 2, 3, 4, 5, GUI. Okay, and now the GUI is running normally. Okay, we paused the main thread. The main thread was asleep, preventing, now all these objects have been built, they're sitting in the heap, they don't really mean anything in the heap yet. The main thread sleeps for 5 seconds, then all of a sudden the main thread says, okay, now launch the event dispatch thread. Make the GUI visible and launch the event dispatch thread. This guy's not there, so then the system just keeps running. Okay, all right, okay. Yeah, and that's what I want you to do. Try these experiments at home. Think what happened. What if? The thing is, you have to keep saying to yourself is, what if I do this? What if I do that? What if? What if? What if? Okay. So keep asking questions like that, and try these experiments. These things are set up to be simple so that you can do little experiments with them. They're meant to be experiments. Okay. Now let's see. Let's do 6. Oh, okay. 5 was 2 event handlers for 1 button. 6 is 1 event handler for 2 buttons. Okay, now in the picture here, what that would mean is there'd be 2 GUI objects, but there'd only be 1 event handler, and he is linked to this guy's list and he's linked to the other guy's list. So it would be 2 GUI objects, and each of them has in their event dispatch, in their listener list, a pointer to this 1 handler. So this 1 handler is being called whether you click on 1 button or the other button. Okay, so then you can try 6. There's the 2 buttons. And you can tell it's 1 handler because it's got a counter in it. And see, it doesn't matter which button I click, the counter just continues where it was, because they're triggering the same block of code. Both buttons trigger the same block of code here. These so create 1 button, create the other button, create the single event object, create 1 of these, create 1 of these, create 2 of these, 1 of these, then put him in each of their list. Put that same guy in each action listener list. Okay, then you add each button to the, oh, here's a little trick. You can't add you can't add the buttons that way. It doesn't compile. They didn't write their add method as a variative method, because it was written, this add method was written when Java didn't have variadic methods, and they didn't want to break people's code by changing this add button, this add function. So the add function doesn't act the more modern way where you can just add 2 buttons at once. You have to add the buttons 1 at a time. So that's someplace where Java shows its age. This was written before you had variadic functions. So you can't do this cute little trick here. So you have to add the buttons 1 at a time, right? And then you get 2 buttons. And in this case, I changed the layout manager so you could see the 2 buttons. Before there was 1 button and it filled the whole window. Now in order to be able to show 2 buttons, I have to change the layout manager. So I changed it to a flow layout so you could see the 2 buttons. Okay. If you, here's an interesting thing. What if I don't use a flow layout? Well, let's see. What if I don't change the layout manager? Okay. And run it again. Where's the other button? You want to get? Try to guess. Where's the other button?
On top of it? Underneath?
Yeah, it's underneath it. And I do not know if it's being clicked. Probably not. If it was being clicked, what would happen? Wait a minute. Yeah. Yeah, if it was being
clicks.
Pardon me?
You'd get double numbers.
Yeah, I get double numbers. If I was actually clicking on both buttons, I would get double numbers over here. So one of the buttons is underneath one button is stacked on top of the other, and the one that's underneath is just unavailable to us, which is, yeah, that's just the quirk of the Java GUI. That's why you need these layout managers. Right now, what I did was, by default, the frame has a border layout. And what I just did was I added both these buttons to the center of the border layout. I could fix that by doing this. Put them in different places. But I thought that looked kind of ugly. Okay, but there's my two buttons. One's in the north and one's in the south. I could have put them I could put one north, one center, one north, one east, one north. Pardon? So the default layout manager for a J-frame is the border layout, but I thought it looked better if it was with the flow layout, okay? And if in the border layout, if you don't say where it goes in the center. So now watch this one. One button takes up the whole center, and one button is in the south. And if I don't say center, it defaults to center. It defaults to the center. See, one button in the center and one button in the south. Okay, so that's a little bit of playing around with layout managers. Okay, I thought what looked better. Oh, and what's interesting, and this is actually kind of, I think, good on their part. Suppose I leave it like this, but then I switch to the flow layout. What do you think happens to this stuff?
Overrides it?
Yeah, well, it doesn't override. No, oh no, oh, that's a good point. You mean like force it back to the border layout?
Force it back to north and south.
Yeah, no, it doesn't. Okay, I said use the flow layout. So what's another possibility? Okay, one possibility was this would somehow force you back to using the border layout. What's another possibility?
That the flow just positions them in north and south, however it is.
Well, yeah, but flow has no sense of north and south. So what's another possibility?
Oh,
An exception?
Oh, that's a possibility. What's another possibility? Yeah, one possibility is, oh, you're using a flow layout. This doesn't make sense. Throw an exception. What's another possibility?
Or it ignores the border layout.
Yeah, and that's the one they chose. Which I think is clever, because that way I can switch here between one layout and another, and then say, okay, so it's just going to ignore him. And I think that's actually the best choice of them. Okay? Flow layout, and it ignored the north and south. Why do I like that? Because now if I decide to go back to the border layout, I've got things where I want them down here. See, I can leave the border layout code there, and then I can choose whether I want to use a border layout or a flow layout. I think that's kind of clever. I think that works well. Yeah, they could have thrown an exception. They could have said, you're not supposed to be calling north, south, east, and west when you have a flow layout. Okay, so notice now I'm back to the border layout. So if I'm using a border layout, these guys get paid attention to. If I'm not using a border layout, these guys get ignored. I think that's actually kind of good. All kinds of things notice that that's a design issue. Start thinking like a designer. Think, how would you handle this? You're using the flow layout and somebody gives you a parameter for the border layout. Should you throw an exception with an illegal parameter exception? Should you ignore it? Should you switch to the border layout because they gave you a border layout parameter? Or should you just ignore it? And the Java people said, we'll just ignore it, which I think was the right choice. I think in this case, that was a good choice. Okay? All right. Notice how notice how we keep going back to this picture. and think in terms of this picture. When I have two event handlers for one button, that would, oh, what was that in this picture? Two event handlers for one button. How is that represented in this picture?
The
Two handlers for one button.
the list of
The
event
list will have
listers?
what now?
What you were just saying.
It'll have two items in the list.
Yes.
Okay, this list will have two items. Now, how's that different from one handler for two buttons? One handler for two buttons. How does that affect this picture?
There'd be two lists with the same reference to the same handler code.
There'd be two of these guys with two lists, but each list pointed to this one item. So there'd be two lists and one item as opposed to one list and two items in the list. Okay? Understanding that puts you way ahead of the game of like most programmers. Most programmers actually do not know what it means to talk about one handler for two buttons versus two buttons for one handler. You know, they wouldn't be able to tell you concretely what's the difference between that and that. And over here, the picture is the model. It's the difference between having one button with two items in this list, two different event handlers. Oh, here's a let me do one. Let me stop. Let's do one thing. Two event handlers for one button. Let me do something weird. Give me a, I'm gonna, this will be a little puzzle. What did I just do?
Two listeners for
Two listeners for one button, but
You registered the same listener twice?
yes. So in this picture, what do I have?
two different objects with one
Nope,
event
nope,
list. No?
nope.
Oh yeah, one. Wait. Sorry.
Yeah. I created
One button, one handler.
I created
one button, one handler, two listeners.
Yeah, no. One button, one handler, and kind of two listeners, but be very careful.
Oh, okay.
It's already in the list, so it really wouldn't do anything, right?
No.
Add actions.
I add this guy to the list, and then I add him to the list again.
All right.
So what does Java do when you add the same thing to a list twice?
Does it ignore the second one?
No.
Oh, okay.
No, never. Go back to you. Looks like that.
Oh, two references.
Two references to the same item. So what will happen? What do I think is going to happen now?
Well,
They'll execute the listener code, handler code twice.
Yeah, I should execute the handler code 2 times. I should execute it 2 times. Let's see. Let's try it. This is what I mean by experiment with this stuff. What ifs? Ask all kinds of what ifs. Okay. Bingo. 2 ouches.
uh-huh.
Yeah.
Could
Would
you
you ever
also-
do that? Pardon me?
Could you also like call thread sleep in the handler code too?
Yeah, but yeah, try it. So now my answer is going to be, from now on, try it. Okay. What's this going to do?
Oh, 1, 2, 3, 4, 5 of them.
Does
5
Java
ouches for every
care?
click.
Does Java care? Does Java care if I do something really dumb and weird?
No.
How do I understand that? How do you explain that to somebody? What did I do?
Called the same method 5 times
Because
you have 5 different instances of it within the list.
no, well, 5 different references to it in the
Yes,
list.
references to
Yeah,
it in the
so
list.
there's one, use the words right. There's one instance of the handler. There's 5 references in the list to that one instance of the handler. Okay? And then I can play weirder games still. I'll do a weirder game here. What did I do now?
Oh. A new handle. Can you do that?
Yeah, of course I can do that.
Put a new handle inside the add action list.
What did I do in this picture here? Two monitors. This is where 2 monitors are needed.
Right.
Well, you have 4 references to the A listener, and then 1 reference to the B
Yeah,
listener.
I've created 2 listeners. So there's 2 listener objects. There's 5 items in the list. 4 of the references point to one object and 1 of the references point to the other object. So I've got this handler referred to 4 times and this handler referred to 1 time. So what does my output look like when I run it?
Ouch, ouch. No, it's ouch, 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 ouch,
Yeah.
ouch.
There'll be an ouch. We'll see. Well, actually, it did them in the reverse order I put them in. It did, see, 3 ouches in a row, but those were at the end. So it actually executed them from the bottom up. Notice that we can see now that it executed them from the bottom. Because why? Why is it? That makes sense.
Is that a stack?
Yes. So the first in, the last in is the first one is the top of the stack. See, he's at the front of the list. He's next in the list, then they're at the farther back in the list. So they called them in that order. So it got an ouch, 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 ouch. Okay. All right, we've run over. But notice, play games with this stuff. Ask yourself weird questions. Can I do this? Can I do that? And the thing is, it's this picture. This picture is the model. And I don't know of a book that's actually drawn this picture. If you see this picture in any book, let me know, because they don't usually explain this stuff very well. But I think this picture captures what you're trying to do. You know, you've got an item that creates the events. It holds a list of pointers to handlers, and then when an object comes in from the operating system, from the Java virtual machine, it looks in this list and calls the handlers. And then you can start explaining wacky code like this, because now you have a frame of reference to make sense out of strange things like this. Okay, so we've gone over. Let me close this. Okay, but there's a ton of these examples in these folders, and that's what they're there for, to try to be simple examples that you can do experiments with, simple enough that you can play around with them. That's not the case over here in the renderer folder. These are not simple examples that are easy to play with. So that's what this other folder is for. This is the folder of simple examples that you can try to play with. Okay, so look for a homework assignment that's going to be using this GUI stuff. And we'll probably still talk about this a little bit more when we come back, because it's useful. It's really useful. Even if you're going to be a JavaScript programmer, this is the idea you need to understand events and event dispatching, as people refer to it. You're seeing the core idea of so much stuff that goes on. Okay, so let me go ahead and stop sharing. Have a nice vacation, so to speak. Yeah, and we'll meet again in a week. Okay. And if you have any questions about anything, please send me an email or anything. So if you have questions, please write. Okay. Have a nice weekend. Bye.